Lesson 1-6, Relations. Our essential question is, what are the 3 different ways to represent a relation? We have 3 new vocab words today. The first one is a relation. A relation is a set of ordered pairs. The next 2 vocab words are the domain and range. The domain and the range we'll talk about today, and we'll talk about again later in the year. Right now, the domain is represented by all of the x coordinates in our ordered pairs. So all of the x coordinates in the relation. And then the range, you may have guessed, would be all of the y coordinates. Later in this course, these definitions will get a little bit more complicated, but for now, this is all that we need. So a relation is a set of ordered pairs. Remember, ordered pairs always have an x coordinate followed by a y coordinate. If we pull out all of the x coordinates, we have what we call the domain for our relation. And if we pull out all of the y coordinates, we have what we call the range of our relation. Okay, now a little graphing review just to make sure that everybody remembers how to graph. Our x-axis is horizontal, our y-axis is vertical. To graph these points, or these ordered pairs, we are going to graph the x-coordinate first. So on the x-axis, positive 3 is to the right 3, and then a y-coordinate of positive 2 is up 2. So right here, this would be the ordered pair, 3, 2. My next ordered pair is 2, negative 1. So on the x-axis, positive 2. Then on the y-axis, negative 1 would be down 1. So positive 2, negative 1. Sometimes ordered pairs have a letter that they want you to label them with. For example, they might say that this is C, negative 1, negative 3. So then I would go to negative 1 on the x-axis, left 1, negative 3 on the y-axis, down 3, like this, and label it with the letter C. The next one, 5, 3, if I label it with D, I'm going to go to the right 5, and then I'm going to go up 3. So right here would be point D. My last 2, negative 4, 3. Negative 4 for x is to the left, so to the left 4. Positive 3 for y is up 3, so this would be negative 4, positive 3. And my last one is negative 2, negative 4. So left 2, down 4, negative 2, negative 4. You don't have to label your ordered pairs unless it's specified that they want them labeled. I just wanted to make sure that you recognize which point I was graphing in which location. Okay, express the relation in the following ways. The relation is a set of ordered pairs, so we've got negative 4, 1, 2, negative 3, 2, 5, and 1, negative 1. We want you to express this as a table, a graph, and a mapping with the domain and range labeled. Okay, so first up, a table. A table, you may recall, is like a T-chart. So I've got a column for X on the left and Y on the right. And then you simply take your ordered pairs, negative 4, 1, 2, negative 3, and fill them in. 2, 5, 1, negative 1. Each ordered pair gets its own row in your table. Okay, next up, graphing. Negative 4, 1, 2, negative 3, 2, 5, and 1, negative 1. There we go. And last but not least, our mapping with the domain and range labeled. So I'm going to put my domain on the left, my range on the right, and this is what a mapping looks like. You have an oval for the domain and an oval for the range. Now, as you fill in the numbers, my first ordered pair, I've got 4, -4, 1. So -4 and 1. The second ordered pair, I have 2 and -3. The third ordered pair starts with 2. In my domain, I already wrote the number 2. I do not write it again. I simply write the 5 in the range oval, and I'm done with that ordered pair. Then the last one is +1 and then -1. Those numbers have not been used yet, so I do need both of them. Then I draw an arrow to map each domain value with its corresponding range values. So for example, the ordered pair -4, 1 looks like this. 2, -3 looks like this. And then 2, 5 also starts at the 2. So it's like that, where it kind of looks like an angle, like you've got a vertex point, because both of those rays start at the 2. And then my last one, from 1 to -1. That's what a mapping looks like. All of the domain numbers go in an oval, all of the range numbers go in an oval, and then you map them, connect them, just like the ordered pairs were. And you never repeat numbers within the domain and within the range. You simply show that by having either 2 rays start at the same number in the domain, or maybe if the range repeats, two of the rays end at the same number in the range. Okay, now express the relation in the following ways. We're given the table. We need to write the ordered pairs, draw the graph, and the mapping. So the ordered pairs, so from my table, my ordered pairs are 3, 1, 4, 2, 3, 5, and -2, 2. I can graph those. 3, 1, 4, 2, 3, 5, and -2, 2. Okay. And then the tough one, the mapping. My domain and range. So you've seen graphs before, you've seen tables before. It's the domain and range and the mapping that would be the new concepts here. So 3, 1, 4, 2, 3 is already in the domain, so just put the 5 in the range, and then -2, 2 is already in the range. Okay, so this one's going to look a little bit different. So 3, 1, straight across. 4, 2, straight across. 3, 5, I have to go back to my 3 and now go down to my 5. -2, 2, like that. So I have 2 rays starting at the 3, but I've got 2 rays ending at the 2. That's what happens when you've got some of the same numbers repeated. The next one, express the relation in the following ways. Now we're given the mapping. We write the ordered pairs, graph, and table. Okay, to get the ordered pairs from the mapping, remember each of those rays represents an ordered pair. So the first one starts at -10, ends at 0. -10, 0. The next one, -8, -2. Then we've got -3, ending at 1, and -3 again, but ending at 4. My graph, -10, 0 is over here. -8, -2. -3, +1. -3, +4. And then my table, just take the ordered pairs, -10, 0, -8, -2, -3, 1, and -3, 4. So in the table, repeating that x value is fine. You want each ordered pair expressed in your table. All right, so as a summary, you should be able to explain the 3 ways to represent a relation.